I hope you remember you have excellent risk assessment, a great vision to go for your hazard recognition, and you identify all sort of hazards like electrical, chemical, radiation, noise, vibration, environmental, including temperature, gravitational, even physical like slip, strips, and fall, and several all sort of hazards you identify, all risk even associated you identify, but unfortunately the controls are not there, or the effective controls you implemented but later on you couldn't maintain them. Then again the situation would be horrible in that context. So maintainability and sustainability of the implemented controls is one of the most important area we all have to consider as a safety leader, because sometimes I told we can bring improvements overnight, maybe within 1 week, maybe within a month. We can identify all hazards. We have budget from the top manager because Saudi Aramco is coming for audit, or maybe Royal Commission is coming for audit, or maybe third party auditor, they are coming for audit. And overnight we improve everything. But later on, no maintainability, no sustainability. And same the junky behaviors and junky areas we created, right after that audit or visit. So that is not the purpose of safety at all. Just to fulfill your bidding requirements, or just to have some acting in front of your customers. You're not deceiving them. Basically, you are deceiving yourself and making a terrible ground to kill your employees, God forbid, anytime, because you're not giving care that why that controls are so much important to maintain actually. So let's start as per NEBOSH theories, what they're talking about for electrical hazards, how we have to control them. What kind of control measures are important? 11.2 is there. The number one thing is the protection of conductors. Look at the picture on the right side. Protection of conductors. Sometimes the shelf life or expiry date or the wire you selected is excellent. Like you purchase the electric wires as per international standards, as per the environment you are going to use them, and the shelf life or expiry date is brilliant all the way around. You paid a lot of cost, even overpriced, because quality is expensive. But unfortunately, if the insulation is not prevented and have some sort of contact with live conductor, of course, this would be horrible. So cable covering unbroken. So cable coverings unbroken, equipment casing intact, or also inspect to ensure protection is in place. Ensure electrical panels are locked. Like I gave you practical ground, real examples as a safety auditor. Several companies I noticed, even electric panel is not locked. And employees have tendency to put belongings and different things, even eatables. And nobody is stopping them, because that panel is attached with their machine. So they are the custodian, they are the owner. So, and no doubt, openly, they don't have such kind of unsafe acts or creating unsafe conditions, but still it's a bad practice. If we have safety inspectors every day going into every nook and corner of the company, then he must see what is inside the panel as well. And electrical panels need to be locked. Even I would recommend, put some sort of rubber mat in front of the panel. Don't just rely on your safety shoes or your earthing or grounding system. Even though they are also best protective measures, but still we should think 360-degree actually, the best solutions. Strength and capability of equipment. Electrical equipments must be carefully selected to ensure that it is suitable for the electrical system that will become a part of task that will be performed and environment in which it will be used. So suitable to the electrical system, the task and the environment. So system, task, and environment have to be considered before even we select any electrical equipment. No electrical equipment should be put into use where its electrical strength and capability may be exceeded. No electrical equipment should be put into use where its electrical strength and capability may be exceeded. So very careful use. Now, what we truly need to consider, especially for the strength and capability of equipment, how much it is resistible in shape of weather, what natural hazards we have to avoid, like gnawing by rats, extremes of temperature and pressure, like heat from motors, dirty conditions. That is why I always say housekeeping means even the cleaning of hidden areas, because in the hidden areas, more chances of dust accumulation, along with the humidic kind of environment. So humidity plus dust, and if some oil vapors are also coming from the machine, then that would be more terrible accumulation of dust. So with that dirty conditions, not acceptable. And corrosive conditions, liquids and vapors like splashing and flammable substances, foreseeable mechanical damage. So before you select any equipment, make sure they are very much strong and capable in these conditions. Now, protective systems and devices, fuses and miniature circuit breakers, earthing, isolation of supply, double insulation, residual current devices or reduced and low voltage systems. So these are the protective systems and devices. Fuses, miniature circuit breakers, earthing, isolation of supply, double insulation, and RCDs. We also have GFCI, but that is for 110 electric power tools like ground force circuit interrupter. And for 220 or above, we can use RCD, residual current devices, and reduce and low voltage system as well. Now we have a group exercise. Consider two appliances in your home with different protection methods. Explain how each works and the advantages and limitations, like an earthed washing machine, RCD and electrical mower, fuse on a small lamp, double insulation on a laptop transformer, and circuit breaker on main electricity board. So safety starts from me, safety starts from you, safety starts from our home first. So humble request, the moment you go back today at your home, just have a look into your uh, electrical systems at home. And if you believe any gaps are there for earthing, for some protections are not there, just call the electrical technicians and make sure you have the safest system, mashallah. Because after all, your home, you are the only hero for your family. No contingency plan, no backup, right? So for our safety, no harm to start safety system and implement in our home first. Like I gave you an example, during construction, I incorporated almost all the standards and make sure there isn't any chance of, God forbid, some sort of incidents. Still probability will be there, but that is under control and negligible. We tried our level best, now everything is in the hand of Allah, right? But what I mean is it all starts from home, starts from you, starts from me. So go back and you can have a look, what are the advantages and limitations and how you can remove those limitations. Now let's discuss one by one, like fuses and miniature circuit breakers. We call them MCBs, fuses and MCBs. Fuses mean prevents current overload. Fuses prevents current overload. An overcurrent protection device, immediately it will break. So weak link in a circuit overheats and melt if the current exceeds the fuse rating. Designed to protect equipment, not people. So what are the advantages and disadvantages? So above all our advantages, let's consider, because it's less, not expensive, so easy to change. Several other advantages we can mention, but I'm more concerned about disadvantages. What are the disadvantages of fuses? Any one of you please want to highlight? What are the disadvantages of fuses? Over to you, please. Disadvantages of fuses. Yes, please. I'm waiting for your answer. You can reply in the chat box or even you can speak up. It's up to you. Yes, please. Disadvantage of fuses.
Assalamu alaikum.
Walaikum assalam.
Yes, this fuse is very important to if there is, yani, it will be like a safety part of stopping continuous electricity in case of fire or overload or for example of isolation even if for example it will be like some work for maintenance team want to work for this part of electricity. It's part of this fuse can be removed as isolation of energy. So that's it from my side.
Thank you very much. So nice of you. So I totally agree. A lot of benefits and advantages are there, even mentioned by Nibosh, But some of the disadvantages, of course, comparing to the circuit breakers or the safety breakers we have, it is still kind of a weak link, but in several systems, it is still being used. The reason is any sort of overload or, or any short circuit, immediately that fuse will melt out and blow off, and the disconnectivity would be there. So we can save that gentleman, but of course, it's cheap also. That is another advantage. But disadvantage is comparing to, the circuit breakers. It is not reliable, and also you need more time to change, and sometime you truly need to find the location which fuse, is melted and that area is disconnected actually immediately because of any reason, maybe overload, maybe some short circuit, maybe some any other reason, but of course that fuse still helpful. So some of the disadvantages could also be low breaking capacity, and also the protection of fuse is not reliable. These are some of the disadvantages. So let's talk about miniature circuit breakers like MCBs. Even though they are also similar to a fuse, they prevent current overload, an overcurrent protection device, electromechanical device, and trips a switch can be reset, tamper-proof, designed to protect equipment, not people. So this disadvantage is enough that it is not designed to, uh, protect people actually. But yes, it can protect the equipment. But on the other side, it is expensive also comparing to fuses. This is a kind of disadvantage. Now let's talk about earthing. In the event of a fault, provides a safe path to earth. Outer metal casing connected to earth by wire. Electric shock should be minor. Advantage and disadvantage we can discuss. What are the disadvantages of earthing? Advantages we all know. It will give away even to the sky electricity. That would also be find a way directly to the land actually instead of or even to the. But what are the disadvantages of that earthing? Any one of you, please. Disadvantages of earthing. Yes, please. Disadvantages of earthing. Advantages we all are clear. It is helpful. It avoid and it keep us safe. From several electrical incidents. Keep safe our buildings even. But what are the disadvantages of earthing? Because the high over voltage, sometimes they can or maybe occur, between all live parts and between live parts and peak conductor as well. And one of the disadvantages like possible over voltage or stress on equipment actually, installation of the installation. So these are some of the disadvantages of earthing. But somehow we see earthing everywhere. Like we get even at our home, the washing machine, our building, like my home is also have earthing from skylighting. Like I just place one wire at the top and directly grounded, and in the ground. So even from skylighting, it will be helpful because the electricity you need to give that electricity away. So all our equipment machines and even the complete wiring of our home, we always put one wire for earthing in. That is also advantage. No, isolation of supply, isolation of supply, the removal of electrical movers, removal of electrical power from a circuit or system. Now here, before we discuss anything from NEBOSH side, we can have a clear understanding what is the difference between LOTO and isolation. Because talking about isolation, here he is talking about isolation. But my question is, what is the difference between LOTO and isolation? And which one is more beneficial by the way? Yes, please. So what is the difference between LOTO and isolation? That is the question. Any one of you, please, voluntarily, if you want to elaborate, the difference between LOTO and isolation, and which one is more effective, by the way, especially for electrical systems. Over to you, please. Any one of you. Yes, please. The difference between lockout tagger and isolation, and which one is more effective? which one is more reliable even? Lockout, tagout, or isolation? Even both methods, they are blocking, they are disconnecting the electric energy, But why he didn't use the word lotto? Why directly isolation?
Assalamu alaikum.
Walaikum
Yes,
assalam.
yes, this isolation, you will isolate the source of power,
Mhm.
and you either for electricity remove the fuse or use the breaker and to isolate. Also do this Bluetooth يعني for lockout this will lock and tag, or he will use the tag of and lock for for stop this energy of source,
Mhm.
so nobody will operate this for this breaker even, or this panel unless with only this authorized person. So there is a lock and there is a tag of this person, this information. Yani,
Excellent.
yeah.
Mhm. Excellent. And this is the only system where you will not trust on anyone. Like your lock, your key, you are the one going to put your lock, and you are the one going to put off your lock or remove your lock. So you will not say someone take my key and open the lock. Even isolation basically is more effective in that shape that you remove the breaker, you remove wires, you remove the fuses, and that means you make sure there is no chance of anyone to even start up that breaker or something. But in lockout tagout, sometimes what is happening is you just turn off the breaker and you lock and put tag. But still there is a probability, someone can open and turn on that breaker and you are working, God forbid, in that area. So still incident could happen, And sometimes you forget to put lock and tag and directly, you just turn off the breaker. And that is another way. And unfortunately, no second chance, especially if, like one of the incident happened, the gentleman, the machine operator, he just went for kind of a tea break, and it was a game of 5-10 minutes. A maintenance technician, along with the safety officer, they came near to the machine, and they thought it's a 5 minutes, so we can inspect, and no need of isolation or no need of a lockout or tagout. Anyhow, they just turn off, the relevant breakers. That is what the positive thing they have done actually. But no lock, no tag, no isolation at all, no verification, and even a buddy system like two gentlemen were working. Now, the moment they went to the other side of the machine operator arrived, and without thinking anything, without following the machine startup procedure, that before start the machine, he should take a round and check everything, then there is no possibility of any mishap, God forbid. So he didn't do any inspection and he started, it turned on. And because of that hydraulic energy, the person, just crunch actually. It's just, I can't show you the video actually because everyone psychologically is not fit to see such kind of terrible videos, I have that video also. But because of that hydraulic energy, the person is hit, like his heart was just, flattened. And within seconds, is no more. And really hard to allocate who is the culprit. Either the machine operator who didn't do inspection, who didn't care. Like if we are starting our car and not taking any round, and maybe a cat is there, maybe a small baby, less than height of your car, and you simply started up. So, we any machine we are starting up, we definitely have some pre-inspection or some kind of, pre-startup inspection also. But that procedure was ignored by the operator. And before the operator, the technician or the safety officer, they ignored the procedure, lockout, tagout, or isolation. And the terrible consequence was the person who just died within seconds, actually. That is why I mentioned, it's hard to get second chance. Unexpected startup of machine, unexpected release of any energy, it's always destructive. Now, what is double insulation? We have live parts or parts that might become live under fault conditions cannot be easily touched, often achieved by having two layers of insulation between live conductors and any external metal surfaces, or external surfaces are non-conductive like plastics. We also call them the class 2 equipment, and no need for earth protection because double insulation is there. So you can consider these are some of the advantages, but disadvantage, what I normally see, they are expensive, even though beneficial, but of course it's expensive. And if any damage because of heavy equipments or any loading unloading is going on, or because of any other reason, because of environmental aspects or impact, if that would be damaged and you are just relying on double insulation and inside you have live electricity, so that is another disadvantage, because it's not like 100% solution for the live cables to be avoided. Now, residual current devices specifically designed to protect human life. These are the constantly compares current and live and neutral, and also sensitive to small current imbalance like leak to earth, very sensitive with the 30 milliampere and very fast with 40 millisecond, and can be used as part of a plug, as standalone device, hardwire into distribution system. So residual current devices normally, you can consider we use them for 220 or 240 kind of volt. The power tools or equipment are designed for, but I didn't study anywhere that it can be used for 110 also, because for 110 we use GFCI like ground force circuit interrupter. Now, the reduced and low voltage systems, as voltage is reduced, so the shock current is reduced. As voltage is reduced, so the shock current is reduced. So UK voltage 230 step down to 110 for portable tools. So portable power tools, 110 are mostly recommended, especially in UK. And this is good strategy, at least the portable power tools should be designed from the manufacturer with 110, and our system should also be supporting that 110 through plugs, or the wiring should also be done accordingly. 50 volts equipment, SCLV, like 50 volts equipment. Now we have a group exercise. What factor do you think should we consider when selecting suitable electrical equipment for use on a construction site? I repeat again, what factors do you think should be considered when selecting suitable electrical equipment? Like you are the procurement manager and you are going to buy the electrical equipment for your construction site. What factors you will consider, before even you decide to buy? But before placing your purchase order, what factors do you think should be considered, especially when selecting suitable electrical equipment for use on a construction site? So construction site, that means open air, sometime covered area, sometime uncovered area, sometime under direct sunlight, sometime in winter season. So all sort of conditions, sandstorm, think about every aspect, especially in our Saudi Arabia, mashallah. So accordingly, mention what factors critically are important before even you select, or the selection criteria for electrical equipment. Over to you, please. Any one of you. Yes, please. What factors should be considered when selecting suitable electrical equipment for use on the construction site? Yes, please. Any one of you. Like you are the one going to buy, going to select electrical equipment, the suitable one. What factors you will consider? Yes, please. Mhm. Any one of you, please. What factors do you think should be considered when selecting suitable electrical equipment for use on a construction site? Even though you have a chemical site, but let's see what you mention. You can reply in the chat box or you can speak up. It's all up to you. No issue. And that side might be constructing your beautiful home, mashallah, beautiful house. So what type of suitable electrical equipment you'll select? And important factors you have to consider. Yes, please. Any one of you, please.
For this one, competences. Can you hear me?
Yeah, please. Your voice is quite clear.
Yeah, for this one, competence is always related to efficiency or success of something.
Okay. So we can define competence by looking into the success rating and kind of efficiency within that gentleman, and then we're going to define he's a competent one. Or I'm sure in Sadara you would have competency metrics for all of your employees, for each profession, for each individual, even at some level, and you're going to make sure that according to their job descriptions or according to their allocated job responsibilities, they are fully competent, or if there is any lacking point or any responsibility they are facing some difficulty to fulfill or hard to meet the requirements, then of course you plan some trainings and make sure that competence is achieved. But what is the competence in that term? We have to make sure the gentleman is fully knowledgeable, practically sound, having some experience, and educated, in other words. So, but in electrical terms, in electrical systems, what is the competent person? The knowledge of electricity, experience of electrical work, and he must be capable to understand the system and understanding of hazards and precautions, and ability to recognize whether safe to continue work, yes or no. So in electrical safety, the competent person have that particular meaning, like the knowledge of electricity, the experience of electrical work and understanding of the system, understanding of hazards and precautions, and of course, ability to recognize whether it's safe to continue work or not. So that is all about the competence of electrical systems operators or electrical technicians or engineers. Now, to support them, surely we required a use of safe systems of work, like work that, whenever possible, work on or near live electrical equipment, only under exceptional circumstances and if controlled tightly. So we need two sort of safe systems of work. One for dead work, like where no electrical energy is there, all are isolated or properly locked and tagged, or there is some sort of project where live electrical equipment they're going to tackle in. So for both areas, surely we require a safe system of work, like all SOPs, procedures, regulations. So working on near live electrical systems, no live working unless no alternative. That is the number one rule. If essential, safe system of work to include is like permit to work, competent persons, insulating like PPE such as boots and gauntlets, and also insulated tools and equipment, and designated work area if essential. Otherwise, we have to consider no live working unless no alternative. Now, what is isolation? Usually require the breaking of the circuit or physical securing of the breaker in the circuit and some form of label or tag. No, just I got one idea. So let me go to that area. Maybe I just want to highlight how I'll just encourage you, go on OSHA website and go to help and resources, and you will find training and you will find videos. If you click on videos, there are, even though these are fatalities or kind of accidents happen, but in animation format, they just present for our training, what lessons learned. So if you go to the videos, you will see alphabet wise, like for carbon monoxide, starting with C, complaints, confined spaces, construction, even cranes, drowning hazards, electrical. So what I mean is, for each alphabet, they have uploaded the videos, and whenever you get time, just have a look into it, and surely you will learn a lot, because they have mentioned what went wrong and what are the best controls, to avoid the repetition or reoccurrence of such accidents. So you just can go and click those videos and see, like ergonomics is also there, fall protection also have several videos, fireworks, floods, even general safety, healthcare, health, illness prevention, holiday workplace safety, inspections, lockout tagout. Like if we open lockout tagout, let's take, because since we are discussing that one, let me see if it is going to open clearly. So are you getting some sound of video or no sound?
Yes, there is sound.
Okay.
An electrician was working on an open electrical panel on a ship. He needed to add a new cable and attach it to a breaker within the panel. The electrician identified the isolation breaker that fed the entire panel on the schematic drawing. The electrician de-energized the breaker and properly tagged out. As the electrician was fitting the new cable into the panel, his left hand came into contact with the panel's main bus bars. 440 volts of current passed from the bus bars through his left hand, across his chest, and out his right hand that braced him against the panel, electrocuting him. At some point, the tagged-out isolation breaker had been cross-wired with another breaker. The electrician did not know that the panel he was working on was never de-energized. Let's look at some of the contributing factors that led to this fatality. Employees should verify the location of all energy isolation points. Employees must check or test electrical panels or electrically powered equipment to ensure they are, in fact, de-energized before working inside them or within the vicinity of exposed electrical circuits. Inform all contractors and subcontractors of the ship's systems and/or modifications to the systems prior to beginning work.
So from each video, surely you'll be learning something productive, like if we go back and see anything relevant to electricity in alphabet E. So we will find electrocution works safely with ladders near power lines, or work safely with cranes near power lines, or repair welder electrocuted. So let's take an example of the ladder. So whenever you get time, just you can open it. This is the last video I'm going to share, but I'm just motivating. Whenever you get time, just go on OSHA website and keep learning, from the accident. This is the best way to learn from the mistakes of others. If you can't learn by the mistakes of yourself, then learn from the mistakes of others. And this is the best way for learning. Just 1 minute, if I can share the sound.
Also show what employers. Hundreds of construction workers die every year while on the job, with over 700 fatalities just in the year 2011. The third leading cause of these deaths is electrocution. Electrocutions cause 1 of every 10 construction worker deaths, with nearly 70 deaths in 2011. But these deaths can be prevented. The video you are about to see shows how quickly contact with overhead power lines can result in the electrocution of a worker. The video will also show what employers must do so that the work can be done more safely. Employers have a responsibility to provide a safe workplace and protect workers against possible hazards. You'll see that training workers, pre-job planning, and taking the right precautions save lives. Please be advised, the scenes you're about to see deal with deaths at construction sites and might be disturbing for some people. All scenes are based on true stories. 2 workers were hired to caulk windows on a new 3-story townhouse. There were overhead power lines located 20 feet from the house and about 25 feet above ground level. One worker was using a 40-foot metal extension ladder to reach and caulk the 3rd-story windows, while another worker was on the ground caulking windows. The ladder was extended to reach a vertical height of 31 feet above ground. The ladder's base was set 8 feet from the side of the townhouse. After the worker finished one window, he came down from the ladder. He tried to move the ladder by himself, with the ladder still extended in the upright position. But the ladder was top-heavy and too unstable, and it fell backwards while the worker was still holding it. As it fell, the aluminum ladder contacted the overhead power line near the townhome. Because the worker was using a highly conductive metal ladder, it allowed the electrical current in the power lines to reach the worker. He died instantly. Let's look at the events leading up to this tragic incident and see how it could have been prevented. Originally, the worker climbed down the ladder and tried to move it by himself. Because the ladder was still in the upright position and extended, it was too hard to handle even though the worker was himself a safe distance from the power line. As a result, it fell over and hit the power line. Because the worker was holding the metal ladder when it hit the power line, it allowed current to pass through the worker's body to the ground. Now let's take a look at the worker doing the same task safely. This time, before starting to work, the worker and his foreman inspect the area, including checking for overhead power lines. After checking on the voltages with the utility company, the foreman and the worker discuss safe working distances from the power lines. The foreman reminds the worker of the need to keep himself and the ladder clear of the power lines at all times. As an added safety precaution, a fiberglass ladder is selected for use in this area. While the fiberglass ladder is heavier, it has non-conductive side rails, and 2 workers can safely handle it. As before, the worker climbs down the ladder to move to the second window, but this time, he calls over to his coworker to help move the ladder. The 2 workers first bring the extended section down, and then carry the ladder horizontally toward the second window to prevent the ladder from hitting the overhead power lines. Now that you've seen how to perform this work safely, let's go over some important points to prevent these types of electrocutions at work sites. All workers need to be trained about the hazards. Maintain clearance from overhead power lines. Working too close can expose the worker to an electric arc that could result in burns, a shock, or electrocution, even if the worker does not contact the power line. In addition to maintaining clearance from overhead lines, use ladders with non-conductive side rails as an added safety precaution. Using ladders with non-conductive side rails is safer, but not a guarantee of protection from an energized power line. In addition, ladders are not rated for electrical safety, so it is important to always use safety precautions that maintain safe distances from overhead power lines. Inspect ladders before and after each use. Only use ladders that are clean, dry, and undamaged. For example, if a fiberglass ladder is not kept clean, dry, and in undamaged condition, it can conduct electricity. Don't carry or move extension ladders in the upright position. Get help moving ladders to keep control and prevent accidental contact with energized overhead power lines. If a ladder should accidentally hit an overhead power line, do not touch it. Quickly move away and call the electric utility company immediately. If appropriate clearance from an overhead power line cannot be met, contact the utility company to de-energize and ground the line, or request the utility company install insulation over the lines to protect workers. This example shows the importance of employers following OSHA standards to ensure that workers are provided with a safe workplace. These types of construction deaths are preventable. The protection measures shown here save workers' lives. Use these protections on the job. It could be the difference between life and death. If you would like more information, contact OSHA at www.osha.gov or 1-800-321-OSHA. That's 1-800-321-6742.
So I hope it would give you an idea how we can get help from OSHA. And a lot of standards you're gonna find there, standards relevant to stairs, standards relevant to the exit doors, even the portable ladders, standards relevant to electrical power tools. I mean, even excavation, scaffolding, any process you mentioned there, you can find OSHA regulations, and they will definitely. And I found personally OSHA regulations kind of a more practical, orientation is there. That means you can transform this knowledge into actions, and it's guided in steps actually. Like in the video, even they guided all steps, what exactly you have to do. So whenever you get time, just go on OSHA website and have some more learning and make it kind of a continual effort, because learning and development both are reciprocal. So never stop your learning. Now, let me just give you a quick nutshell. Like if we search, let's see, electrical safety as per OSHA. I just type, this electrical safety, and let's see what OSHA is guiding us. So electrical standard, final rule, occupational health and safety. So we can click here and we can find electrical standard. 910 is the title, standard number. So if we tick, let's see what is showing there. So we'll find, the publication date, the publication type, the federal register number, the standard number, the title, and the standard is starting here. Everything related to electrical safety. Even sometimes what we do is we just copy, we go to the Word and have our own font style, and keeping in our view and highlight the key important points, what OSHA is saying, for electrical safety. So I hope it will help you, inshallah. Now we'll go back to the our presentation. So isolation usually requires the breaking of the circuit, like you watch some videos also, physical securing of the break in the circuit, and also some form of label or tag. Now, preventing buried cable strikes, maybe struck during excavation, can result in arcing, shock, burn, or fire. Several incidents happened, even though we have metal detector, cable detector, pre-excavation checklist, even the permit system is there, but still those incidents are happening. Because whenever the carelessness or some sort of shortcut or might be some lack of knowledge as well, or the right person at the right job is not there, like not certified or using the competent persons, of course, the more probability of such accidents actually. So what are the precautions? Make sure you check plans. You must have detection equipment like CAT scanner. So expose by hand digging or identify the cable. Work near overhead power lines. Look at the picture. A complete safe system of work we need to follow. Usually uninsulated control measures, a range isolation or cover sleeve. Safe system of work and permit to work. Barriers, signs, goalposts, banksman, signaler, even non-conducting equipment we can use. Now we have a group exercise